For this section, we're going to be talking about geometric sequences as exponential functions. First thing I want to talk about, though, is remind ourselves what is an arithmetic sequence. And we talked about this a while ago, but arithmetic sequences are where you add or subtract the same number each time. And if you remember, we did these a while ago. An example of an arithmetic sequence would be like 2, 4, 6, 8, because you just add 2 every time. And we looked for that common difference, and then we had our formula for arithmetic sequences. That's the main idea, add or subtract the same number each time. Now what a geometric sequence is where you have a term and then you multiply the previous term by this constant number. Okay, so we had this example where you send a chain email to a friend who forwards it to 5 more people. Each of those 5 people forwards it to 5 more people. I don't know if people still do this, but this used to kind of be a thing. Okay, and so if we were to count how many emails were generated, the first person generates 5, and then the next time the email is sent out, it goes to 25, and the next time the email is sent out, there's 125. Because each person's sending out 5 every time. So the example, you go 1, 5, 25, 125. This is an example of a geometric sequence because every single time we are just multiplying by 5. We just multiply by 5 every single time. 1 times 5 is 5, 5 times 5 is 25, 25 times 5 is 125. And this multiplied by 5, that's where we get our common ratio. And the way the common ratio can be found is by dividing any term by its previous term. So if you look, 125 divided by 25 gives us that 5. 25 divided by 5 gives us that 5. 5 divided by 1 gives us that 5. All we're doing is dividing each term by its previous term to get this common ratio. And that's the big thing. You're going to have to be able to find this common ratio in order to use the formula for geometric sequences. And a sequence is only geometric if it has a common ratio. So for example, if I had 1, 3, 9, 18, if I looked here, 3 divided by 1, that one had to be times 3. 9 divided by 3, times 3. 18 divided by 9 is 2, so that one's a times 2. This is not a geometric sequence because it did not have a common ratio. I went times 3, times 3, but then I had this times 2, so it wasn't all the same. A geometric sequence has to have that common ratio. So if we look at our first example, we want to determine whether the sequence is arithmetic, geometric, or neither, and we're going to explain. First thing we'll look at is arithmetic. Here I would subtract 128, then I'd subtract 64, and as soon as I see that, I know it's not arithmetic. So I can eliminate that option. Now I'm going to look. What's 128 divided by 256? Well, 128 divided by 256 gives me 1/2, or 0.5. 64 divided by 128 gives me 1/2. 32 divided by 64 gives me 1/2. So for each of these, I am getting that same ratio of 1/2, which means this must be geometric. And since this is a geometric sequence, because I got that same ratio, I'm done. It was geometric. Not arithmetic because I wasn't adding or subtracting the same thing each time, but each time, you can think about it, 156 times 1/2 is 128. 128 times 64 is 1/2. 64 times 1/2 is 32. I think I said this part wrong. 128 times 1/2 is 64. We found that common ratio, and that's how we know it's geometric. And I apologize. I think there might have just been something flash up on the screen. Okay. Now, looking at this second part, we want to see, is it arithmetic, geometric, or neither? Well, is it arithmetic? Well, I add 5, then I add 3, then I add 6. Those aren't all the same, so it obviously is not arithmetic. So I can eliminate that one. Now see if it's geometric. Well, what's 9 divided by 4? You could write it as a decimal, but it would just be 9/4. Then you have your next part, 12 divided by 9. That's 12 ninths, but we can simplify 12 ninths, divide them each by 3. We get 4/3. Now, if you're doing decimals, you can see right away this isn't the same, but also, I know 9/4 isn't the same as 4/3. As soon as you see two ratios aren't the same, you know it can't be geometric. Let's just check our last one, 18 over 12. Well, if I simplify that one, divide them each by 6, you would get 3/2. So now I can see I had 9/4, 4/3, 3/2. None of these are the same. They are all different, so I don't have a common ratio. Since I don't have a common ratio, it's not arithmetic, it's not geometric, so it's just neither. In order for it to be arithmetic, we had to have the common addition or subtraction. Geometric, we had to have the common multiplication, that common ratio. In part A, we had that times 1/2. Part B, we did not have a common ratio, so it was not geometric.